All right, we'll go ahead and get started, and we'll have more people come as we go on here. Going to go ahead and do CR14 today. Just to let you know, I'm in the process of grading the exams. I've sent a couple emails out already, but I'm continuing with that. So you should get something within the next couple of days as far as what your new adjusted score is going to be and everything else. So we're going to go ahead and do these sections that start with CR. These are called like co-requisite review. So these are some review sections, but these are some sections that it's always good to review these because people always have questions on this kind of thing. So this is a factoring that we're going to go over. We're also going to cover the imaginary numbers. That's another one because basically both of these sections, the CR14 and CR15, we need both of these in order to go on to the Chapter 3 section that's on quadratics. So that's why we're going to do these two review sections first here. So this one's on solving it. So basically we're going to solve quadratic equations, and you see all the 4 different ways that we're going to learn to do that. So we're going to start with the factoring. So quadratic functions, first of all, there's one question in the homework that asks you whether something is in standard form or not. And how you know something is in standard form is from this right here. It's got to be the f of x is ax squared plus bx plus c, and the a is not equal to 0. So you have to have it in that standard form. This could be a 0. It's typically a 0 on this side, but it's got to be the descending powers is the way you got to have it there with all 3 of these appearing. So that's how you know which one to check for the homework. Okay, so we're going to go into the factoring. We'll start with first. And so we've probably taken a look at ones that look like this already, but there's one like that in the homework. So just as a quick review for these, we're using what's called the zero product property. That just means that if you have 2 things multiplied and equals 0, either A has to equal 0 or B equals 0 in order for the whole thing to be equal to 0. So for this problem above here, you would just do x plus 4 equals 0, and you would do 3x minus 7 equals 0. It's already factored. And so future problems will have to do the factoring step first and then separate it like this. But for each of these, we have x is equal to -4 and x is equal to 7/3. And those would be your 2 answers. It's already factored, so we just set them both equal to 0. Next one, we're doing find all roots. Okay, so all roots just means that you're basically just solving this and setting equal to 0 is all that really means. Now for something like this, we do have to do a factoring step here. Notice that there is a common factor of x that's common. So what I'm going to do is I'm going to factor out the x, and then I'll have something inside the parentheses that's going to be equal to 0. Factoring is basically a way of dividing. So if you take each of these individual pieces and you divide them by x, that's what you're going to get inside the parentheses. So x cubed divided by x is going to give you x squared. 25x divided by x is a minus 25. So we get that inside. You can always check your work to see if you did the factoring correct by multiplying it back through, and you should get exactly what you started with. And you do in this case. X times x squared is x cubed. X times minus 25 is negative 25x. Now we're not completely done yet. If we want to do this completely by factoring, then this is a difference of squares. And so we get a minus 5 and plus 5 is what that breaks down into. So x squared minus 25 goes into x minus 5, x plus 5. Basically, you're looking for 2 numbers that multiply to make negative 25 and add to be 0 since we don't have a middle term that's inside there. So we get this. Now we're going to use the zero product property in order to find the answer. Each of these we're going to set equal to 0. So x equals 0, that's automatically one of our answers. Then we have x minus 5 equals 0, x plus 5 equals 0. And if you solve these, then you get 3 answers. X is 0, 5, and negative 5. So we get 3 answers there in that case. This next one, it's very easy to make a mistake on this kind of problem. The first thing that you might think of on a problem like this would be to divide both sides by x. But you don't want to do that because that's going to eliminate one of your answers. The correct way of doing this is to get it equal to 0. So I'm going to subtract the 24x over to the other side first. And then I'm going to do the same factoring step I did like the problem above. I look for common factors to take out. So I know x is definitely a common factor, but a 4 is also a common factor. And so I'm going to factor out a 4x. You're just looking for the biggest thing that divides evenly into the two pieces that you have there. If I take 4x squared and divide it by 4x, I'm just going to be left with an x. If I take 24x divided by 4x, I'm just going to get a 6. And it'll be a -6 because there's a minus sign above there. Again, you can always check to see if this is correct by multiplying this through each thing. So 4x squared and then minus 24x, that's done correctly. Now we use the zero product property, set both of those equal to 0. You're going to, if you divide both sides by 4 here, you get 0. And then this one, if you add 6 to both sides, you get 6. So you get two answers, 0 and 6. Now, if you were to divide both sides of this by x first, you would have gotten the x equals 6, but then you would not have gotten the answer x equals 0. So it's actually not algebraically correct to divide both sides by x, and that's because you might actually be dividing by 0 in the course of doing that. So you never want to do that. Don't divide both sides by a variable. Instead, you want to move one of them over and set it equal to 0. That's the correct way of doing that. So here's another one that this is kind of like a you try it kind of problem, but it's similar to one above. I'll just go ahead and do that for you. These you try it problems, these do appear in this co-requisite review section because I'll be using these in the fall when I'm teaching 126E, and we'll have probably people pause and kind of do these in class together and that sort of thing. But since we have kind of a remote class here, I'll just go ahead and do these for you as an extra example. So this here, what you want to do is you want to subtract that over and get it equal to 0 once again. So same thing applies. You don't want to divide both sides by x. Instead, we're going to move one of these over, get it equal to 0. The common factor here is going to be a 3x that's common there. Okay, so 3x we're going to pull out, and that's going to leave you with a x squared minus 27 is what you're left with over there. Okay, so now that we have this, I'm sorry, minus 9. What am I doing? I forgot to take out the 3 from the negative 27 divided by 3 is a 9, so didn't do that part. There we go. So 3x cubed. The reason why I knew that, by the way, is if I would have left this as 27, I would have multiplied 3x times 27. I wouldn't have gotten 27x left over. So that's why it's a good way to check your work to make sure that's done correctly there. So 3x cubed minus 27x is correct. Then we can do one more step here. We can do the x plus 3, x minus 3. That's the difference of squares again. And now we're just going to set all of these equal to 0 to get the 3 answers. So divide both sides by 3, we get x is equal to 0. If you subtract 3 from both sides, you get a negative 3 here. Add 3 to both sides, you get 3. So 0, minus 3, plus 3, those are the 3 answers we get from this one. Now, another one that is easy to make a mistake on is this next one here, where you don't have it equal to 6. So a common mistake that I see students making is doing this and doing this. Actually, this is wrong. That's the wrong process. When you set this equal, you're using what's called the zero product principle that we were doing for the previous problems. That only works if it's set equal to 0. Does not work if you have it set equal to another number. So these kind of problems, you don't want to set it up like this. Instead, you need to multiply all this out and then bring everything all over and set it equal to 0. That's the way you want to do these. So let's go ahead and FOIL this out. We're going to do x times x is x squared. And then x times 4 is 4x. We'll do the inner terms. These here, 3 times x is 3x. 3x there. And then we have 3 times 4 is 12. And it equals 6. Okay, so we have that. We're going to add some like terms together. X squared plus 7x plus 12 equals 6. And then I'm going to do that, subtract 6 from both sides to get x squared plus 7x plus 6 equals 0. Okay, so now that I have everything all set equal to 0, at this point, I'm now going to factor it and set it equal to 0. So I get x and x here. It's a 1, and I want to look for two numbers that multiply to make 6 and add to be 7. So I don't want to use 2 and 3. I want to use 1 and 6 there. And both of those right there, now I can set them equal to 0. X plus 1 equals 0. X plus 6 equals 0. I get x is equal to -1. X is equal to -6. So now I have the final answer, -1 and 6. So again, if you have a problem like that where it's not equal to 0, you want to always make it a 0 before you factor something and set it equal. Okay, next one, I have one that has 4. Actually, let me just want to go down too fast here, make sure you can get the answer for this one. This next one I'm doing, and the next two of them, there's a you try it problem as well. These are ones that have 4 pieces. Now the ones that have 4 pieces, these have to be factored by using the grouping method. The grouping method means that we're going to factor the first 2 pieces and the second 2 pieces separately. So 2 separate things that we're going to do. So we're going to look at the first 2 and we want to pull out a common factor. In this case, all there is that's common between that is going to be x squared only. And you get x plus 11. Now for this over here, both of them have a minus sign, so I'm going to pull out a minus. And then both of these, they're divisible by 11. Okay, so I can pull out an 11 from both of these. Now what's left over is, if I take, for something like that, actually I can use, if I look at both of those, you're trying to find the biggest thing that goes into both of those. And if I look at that, then actually it looks like I can pull out the 121 actually is what I want to do there. 121 does divide into 1331. So if I take out -121, I get an x here. If I take a negative out of a negative, that's going to turn this into a plus, and I'm going to get an 11 left over from that. If I take 121 times 11, I'll get 1331. So notice what happens at that point is I have 2 things that repeat. Well, now this is going to be the common factor that I'm going to pull out. So I'm going to do x plus 11, pull that out. Now, if I get rid of both of these, what I have left over is x squared and minus 121. So x squared minus 121 is what I have left over. I have another difference of squares, so we can factor that. That's going to be x plus 11, x minus 11 that I get for that. That's another difference of squares. Okay, so I have all these pieces. Now x plus 11, if I'm setting these equal to 0, this one I only have to do one of them. There's 2 of these that are equal to 0, but I only need to put one of them. Solve for one, then I have x minus 11 equals 0 as well. So I'll get x equals minus 11, and I'll get x equals 11. So I get -11 and 11 as my two answers here. Let's do one more of those. We'll do this you try it problem here. So for this, again, you're going to factor the first 2 and the second 2 separately. The first 2, we can pull out an x squared, and we get x minus 12 for the first 2. The second one, 144 does divide into 1728. So I'm going to do minus 144. I'm going to pull out there and I get x. Again, this will be, okay, so I'm pulling out a negative this time to make that a positive x. If I have a positive, I'm pulling out a negative, and this is going to become negative. So this is negative 12 I get, because 144 times 12 is 1728 on that. So you should always be, when you do these kind of problems, these problems are purposely set up to where you should always get the same thing repeating inside, like x minus 12 and x minus 12. If you don't get something like that on this problem, you want to go back and check it again, because it always works out to where it should be able to factor. You should be able to factor out the common factor there. You're left with x squared minus 144. As in the previous problem, you can factor this by using the difference of squares. So x plus 12, x minus 12. And I have the different pieces here. I have x minus 12 that's repeating. I only have to put it once. And then I have the x plus 12 equals 0. So I get 12 and I get negative 12 as the answer for those. So that's how you do those. If you have three pieces like that, there is one of those kind of problems that's in the homework. So that's how you want to tackle that, is by using the grouping method. All right, now the rest of these, solve the equation. Okay, so solve the equation just means that we have to factor it instead of equal to 0. That's all we have to do there. Now in this case, you just have a factoring problem. We already looked at one that was actually the same one we did previously. And just to review that, look for two numbers that multiply to make 6 that add to be 7. So I'm going to put x here and x here, 1 and 6. Both of those are going to be positive again. You can always multiply it through to make sure you factored it correctly. You get x squared, you get a 6x, and then 1x is 7x, and then 1 times 6 is 6. So that's how you can tell if it's done correctly or not. Then you just set both of these equal to 0. X is equal to -1, and x is equal to -6. And those would be your two answers that you'd put there. Now, I want to talk about, besides ones like this that just have a 1 in front of the x, I also want to go over factoring problems where you've got another number in front like this. Now, for this, there's two different methods. I'm going to show you how to do it. It doesn't matter which one you want to use. Whatever one's easiest is the one that you want to use on a test. So for this, we've got a grouping method, and we have the bottoms up, or also called the Curvy method, depending on which class you might have had this in previously. But this one here, in order to do this by the grouping method, this is sometimes also called the AC method, depending on where you might have learned this. Maybe you might have learned it in high school. They use AC method also. The way you're going to do this is you're going to take the first term. This is your A, and this is your C term, and this is the B term in the middle there. You're going to take A times C, or 6 times -12. You're going to do that first, okay? And then we're going to get -72. Okay, so that's the first step, is to multiply A times C. Again, hence the name. That's why they call it the AC method. Now, the next thing you want to do is you want to find factors, two numbers that multiply to make -72, but they add to equal the -1 in the middle. So I have 6 times 12. The one I'm thinking of that's going to work is if I have 8 times 9 and then make the 9 negative, that also is going to add up to -72. So this is actually the pair that I want to use here, because 8 times -9 equal -72, but then if you add that together, then it equals the middle term. Now, the reason why we're doing that is because we're going to rewrite the middle term in terms of 8 and -9. So I'm going to do plus 8x. Now, it doesn't matter what order you put these in, but I'll just go ahead and put right out like this. So we're changing the middle term into this, but notice if I simplify it, it just goes back to what I started with. So I'm not changing the problem by doing that. Then you're going to factor it by the grouping method that we already talked about previously when we did that last problem, where you have 4 terms. You're going to group the first 2 terms and second 2 terms together, factor those separately. The first 2 terms, we can pull out an x is common and a 2 is common for both of those. Take 6x squared divided by 2x, you're going to get 3x. 8x divided by 2x is plus 4. Then, since both of these are negative, I'll put a minus sign there. A 3 is common to both of those for 9 and 12. So I'm going to pull out a 3. What's left over is negative 9 divided by negative 3 is 3x. Negative 9x divided by 3 is 3x here. And then you get negative 12 divided by negative 3 is plus 4. So we have that. We got a question there. Okay, so you're looking for, how you chose that is you're looking for 2 numbers that multiply to make negative 72 and add to be the middle term. So if you go through all the different factors of negative 72, there's only going to be one pair that works. There's also, we have 1 and 72. That's not going to work. We have 2 and 36 and so forth, and 3, you know, there's all different kinds of different factors. If you go through all those different factors, so if you do all these and run through all those, so we have it's got to be divided evenly, and so if you go through each of those different combinations, for instance, 3 and 24, you know, all these different ones, you're looking for the combination that adds together to equal negative 1, which is your B term here. So 6 and 12 doesn't work, 1 and 72, 2 and 36, 3 and 24. None of those can be added together in any kind of way to give you a negative 1. So the only one that does work is 8 and 9. Now, because the 72 is negative, that means one of these 2 numbers has to be positive and one of them has to be negative. We choose purposely to put the negative on the 9 because I want that to add up to be negative 1. If I put the negative on the 8, then it would be 9 minus 8 would be positive 1, but I want it to equal negative 1. So that's purposely why I chose to put the negative on the 9. So I'm just working, I have to look at all the different factors and see which one can add up to the B term, the middle term that's there. And that's how you know to choose that. And then there's only one way that works, by the way. So there's always going to be only one set that's going to work. And if you did it right, you should always end up with something like this where you have a repeated term there. So 3x plus 4 is one of them. And then if you get rid of these parenthesis parts, what's left over is 2x minus 3. And so now I have it fully factored. Now it does say solve for x. So I do have to go ahead and set both of these equal to 0 by using the 0 product property. So I'm not done yet. I do have to continue with this here. And if I divide, I get negative 4/3. And this one here, if I add 3 divided by 2, actually, let's go ahead and we'll do it. Let's do it piece by piece first. 3 over there, and then we divide, and I get 3/2 here. Okay. So those are the 2 answers: negative 4/3 and 3/2 I get by doing that. Now, the other method I want to show you, I'm actually going to do the same problem over again, but now I'm going to use what's referred to as the Curvy method. So I'm going to have the same exact problem here again. I'll just write it out so we don't have to keep flipping up to the top. Now, what you're going to do with this is you're still going to multiply these together. Okay, so we're still kind of doing the 6 times negative 12, but the difference here is that when you multiply, the first term is going to disappear and it's multiplied by the end. So what's happening is you're actually changing the original problem from what it originally was to this. So we take the first number times the last, the first number disappears. Okay, so you get x squared minus x minus 72. Now that we've eliminated the number that comes in front, it becomes an easier problem to factor, because now you're just looking for 2 numbers that multiply to make negative 72 and add to be negative 1. Now, we already did that up by going through these factors above there, and we determined it was 8 and negative 9 plus 8 and a minus 9. If I multiply this, I get x squared minus 9x plus 8 is a net minus 1x, and then 8 times negative 9 is negative 72. So we have that. But notice that if I just set this equal to 0 now and get negative 8 and 9, that wouldn't be correct because this is not the original problem I started with. So if you're going to do this bottoms up method, then what you end up doing is the number that disappeared, you're going to bring that back in again, and you're going to write it underneath each of these two factors. So the 6 originally disappeared. When we write the 6 underneath each of these, we're going to reduce our fraction, very important to reduce, like this. And if I reduce that, then I get 3/2. At this stage, this point right here, I can now set this equal to 0, x plus 4/3 equals 0, and x minus 3/2 equals 0, and I get x is equal to negative 4/3, and I get x is equal to 3/2. I get both the answers that way. So this is called the bottoms up method. That's because if you were to put this back in the factored form again, the bottom number here would come up next to the x. So I could move the 3 into that position and make it 3x plus 4. And then I could also take the 2 and move it up into that position and make it 2x minus 3. However, because we're solving this for 0, that's why I'm not doing that. I'm just going ahead and leaving it in this format, just like that. Okay, and that's the two different methods that you would use on that. Now, it doesn't matter what method you use. You could also do, if you wanted to do the trial and error method, if you're used to doing that before, where you just go ahead and write the 2 parentheses and just do a guess and check and just try different combinations until you get the original problem. You could do that as well, but I'm not showing that method only because that sometimes takes a long time. There's a lot of different factors to write out. That's why I'm purposely just showing you these 2 methods only. But again, if you're comfortable using the trial and error method, by all means, you can go ahead and use that method as well. And if you don't like one of these 2 methods, then you don't have to use it. If you like the grouping method better, go ahead and stick with that. Whatever one makes more sense to you is the one you want to do. If you are going to do the bottoms up method, just don't forget to do, this is the step that everybody forgets to do, is putting the number that disappeared, putting it back in underneath each of these. That's the main one there. Now I'm going to do another one here. And by the way, grouping method only works, by the way, if there's no common factors. So there's a 6, a minus 1, and a negative 12. There's no common factors between that. That's when you want to use bottoms up method. If there was a common factor, like if it was a 12 minus 2 minus 24, something like that, you want to take out the common factor first before you do the bottoms up method. That's the only thing you have to remember. If you're going to use the grouping method will work no matter if there's a common factor or not. It's still going to work when you do that. Let's do another one where we're going to do by grouping method and the bottoms up method, just to have one more to show you. Now, before we jump into that, we need to make sure this is in the proper form first. The way this is right now, we need to go ahead and multiply that out first and set it equal to 0 before we can jump into the grouping method or bottoms up method. So let's do that first. If I multiply this by x, I get 2x squared minus 19 minus 19x equals negative 35, but it's not in standard form because it's not equal to 0. So I'm going to do one more step, and I'm going to add the 35 to both sides. So now I have it in the correct form. I have 2x squared minus 19x plus 35. So I'm going to do this both methods. I'm going to do it by grouping method and by bottoms up method. The grouping method means that you take the AC method, you're going to take these 2 numbers and multiply them together. 2 times 35 is equal to 70. What I want to do now is I want to find 2 numbers that multiply to make 70 and add to be negative 19. Now, if I need to get the middle number to be negative, that means most likely both these numbers are going to have to be negative. So negative 2 times negative 35, that does equal 70, but they don't add up to be negative 19. So I'm going to keep on going. So on my calculator, maybe I'll try 70 divided by 3. That doesn't go in evenly. 70 divided by 4, let's try that. That doesn't go in evenly either. 70 divided by 5. And I get 5 and 14. So I know that 5 times 14 equals 70. And also, if I make both of these negative, negative 5 times negative 14 multiplies to make 70, but then negative 5 plus negative 14 does add up to negative 19. So now this is going to be the pair that I want to use. There's not really anything else that's going to work. I could just keep taking 70. As soon as I find one that works, then I can stop. I don't have to write down all the other factors, but there's really not too many more after this anyway, as it is. But negative 5 and negative 14 is a combination I want to use. So this right here that I rewrote earlier, I'm going to rewrite that 2x squared, and then instead of negative 19, I'm going to split it up and write it as these two here. Now again, it doesn't matter which one of those you put first. I'll put 14 first, but again, it doesn't matter which order you want to write that. Makes no difference. You'll still be able to factor it. So minus 14 minus 5, and then I have plus 35 equals 0. Now I'm going to factor the first two and the second two. The first two, I can pull out a 2x, and I get x minus 7 here. This one, I'm going to pull out a minus 5. I can take out of both of these. This will give me a positive x there. Negative 5x divided by negative 5 is just x. 35 divided by negative 5 is minus 7. It's a plus, but I'm taking out a minus. That's why this is a minus here now. If you did it correctly, you should see the same thing repeating like that. So x minus 7 is a repeated factor. What's left over is 2x minus 5. Okay, so now that's fully factored. I can take both of those and set them equal to 0 now. X minus 7 equals 0. And 2x minus 5 equals 0. I'll get a 7 here. If I add 5 divided by 2, I get 5 halves as the other answer there. So I did the whole problem by doing the grouping method. I'm also going to do this by the bottoms up method as well. So I'm going to write out the same. So let me write out the same thing I had before. I have 2x squared minus 19x plus 35 equals 0. So I'll go ahead and write this out here. When you're going to do the bottoms up method, you take the first number times the last number, and the first number disappears. So you're going to get x squared minus 19x plus 70 equals 0. So first number times the last number, but the first number disappears. Okay, so we have that. All right, so then from here, we're going to look for two numbers that multiply to make 70 and add to be negative 19. We already did that previously for the grouping method, and we found that that's going to be the 5 and 14 again, and both those would have to be negative, so minus 5 and minus 14. Negative 5 times negative 14 gives you 70, but when you add them together, you get negative 19. Remember that if you're going to do it by the bottoms up method, the number that disappeared, you have to write underneath each of these two factors. And then we're going to reduce our fractions here. It's a very important step to do that. You have to make sure you reduce it. At this stage, I can just go ahead and set both of those equal to 0. X minus 5 halves equals 0. X minus 7 equals 0. So I get x is equal to 5 halves and x is equal to 7. Same answers as before. All right. We're going to do this one, and this one you can do by any method. So it doesn't matter which one of those to do. I'll do this one by the grouping method. But remember, first, if you're going to do that, you have to get it into the proper form first. So x squared minus 13x plus 36 equals 0. So multiply that out. And with this, we actually don't, if there's no number in front of the x squared, I should point this out. I didn't mention this earlier, but if there's no number in front of the x squared, then you don't have to actually use the bottoms up or grouping method. Instead, you can just, this is just a straight factoring problem where you can just go directly into these parentheses like this. So grouping method and bottoms up, you only have to do if there's a number in front of the x squared that's not a 1. If it's a 2 or 3, some other number like that, then you want to use those two methods. In this case, we don't have to use grouping method or bottoms up because we can just factor it out this way. We can just simply look for two numbers that multiply to make 36 that add to be negative 13. So if you're not sure about that for 36, you can do 1 and 36, you can do 2 and 18, you can do 3 and 12, you can do 4 and 9. And actually, this one I can stop because I already found the combination that's going to work. These two numbers multiply to make 36. Now they have to be a negative here, which means I want to make both of these a minus, because now negative 4 times negative 9 does give you positive 36, but when you add them together, you get negative 13. So I'm just going to put these together like that. I can just take these directly now and set them equal to 0. So I get x is equal to 4 and x is equal to 9. And those are the two answers on that one. All right, so that was the first method of solving quadratic equations. That factoring takes the longest because it's kind of like the most problems that you'll see is from factoring. That's like probably like half of your homework problems have to do with factoring. So I want to make sure we cover all that. Now there's some other methods here. These other ones are not used as often because they have to be written in a certain way first in order for you to be able to use that. So these problems have to be written specifically in that format, a certain format, in order to use the method. So we're going to use what's called the square root method. Now, earlier in this section, we solved problems like this by using the difference of squares method and did that. But now this time I want to use the square root method instead, which I saw some of you guys doing on the first test, which is a perfectly good method to use. So with this one here, the way it works is you're going to add 36 to both sides of the equation, and you're going to get x squared isolated by itself. Then what you're going to do is you're going to square root both sides of the equation. So we're going to take the square root of both sides. Now remember, when you do take the square root of both sides, you have to put plus or minus on that, because a negative number squared and a positive number squared will get you the same number. So that's why we have to consider the positive and the negative. When you take the square root of both sides, we get plus or minus 6. So the square root of 36 is 6. So that's going to be your answer on this. We get plus 6 and a minus 6 on that. So if I take both of these and square it, if I take 6 squared, I get 36. If I take negative 36 and square it, I also get 36. That's why we get two answers here on that one. All right, next, we've got this other one we're going to put in the square root method. Okay, now this type of problem, you always want to make sure you have the square part isolated, which it already is. So let's go ahead and write this out. If the square was not isolated, for instance, if it was like minus 4 equals 0 or something like that, your first step would be to isolate and get the square on one side. But since we already have that, we don't have to worry about that step. It's already done for us. Now that the square is isolated, what you're now going to do is you're going to take the square root of both sides separately. So I'm going to do 3x minus 2 quantity squared, square root that, and then also if you take the square root of the other side, you're going to do plus or minus the square root of 4. The square root is going to get rid of this square inside, so we end up with 3x minus 2. And then over here, the square root of 4 is 2, so we get plus or minus 2. What I'm going to do with this is I'm going to write two different equations. So I'm going to do 3x minus 2 equals 2 and 3x minus 2 equals negative 2. So I have to set up two different equations because I have two different numbers on the right-hand side there. Now I'm going to add 2 to both sides. I get 3x equals 4. Then divide both sides by 3, and I get x is equal to 4/3. This other one, I'm going to add 2 to both sides. I get 3x is equal to 0 in this case. divide both sides by 3, and I get x is equal to 0. So I get two answers, 4/3 and 0. Those are my two answers from that. Okay, so basically you can only use the square root method if something is specifically written in that form. Then you're allowed to do that. So that's basically the only two kind of these are the only two kind of problems you'll see in the homework, or just ones written out in these two forms. Okay. So that's actually it for the square root method. So now we're going to go to completing the square method next. All right, now complete the square method. We did complete the square already in the circle section. When we talked about the circles, that was actually on our last test that we had, section 1.4. We talked about this. So it's kind of a similar process to that as far as the complete the square steps, like the step 1 and step 2. But when we're doing it by complete the square, we want to first set it up. So a problem like this, here's how you're going to do that by complete the square. We're going to take the x squared minus 6x. We're going to leave that on one side of the equation. We're going to move the 7 over to the other side. And I'm purposely leaving a space in here. Remember, we also left spaces when we did these problems in the circle section. Okay, but for this here, we leave a space, and then we put the -7 on the other side. We're still going to do the step 1 and step 2, the same method we would have done in the circle section. You're going to take the number in front of the non-squared variable, -6, and you want to always divide it by 2 in your first step. In the second step, you're going to square that number, and you get 9. So you're always dividing by 2, and you're always squaring it. The number you get in step number 2 is the one that you need to add to both sides of the equation. So like the circle section, we did the same thing. We added that number to both sides. On the left-hand side, that's going to automatically turn that into a perfect square. That's what we're calling this complete the square, because you're getting this into a format that would automatically factor into this. There's an x that goes there. The number that goes inside the parentheses is the answer you got in step number 1 of the complete the square step. So again, that's the same that we did for the circles. -7 plus 9 is 2. All right, so now we need to solve this. Okay, now like we did before in the square root method, we're going to do the same process here. We already have the square that's isolated. So now I'm going to take the square root of both sides. Again, remembering that you get plus or minus when you do that. When I get rid of this, I get x minus 3 is equal to plus or minus square root of 2. Now this doesn't simplify down any further. I just have to leave it as the radical. So now all I need to do is just add the 3 to both sides. If I add the 3 to both sides, I get 3 plus or minus the square root of 2, and that now is going to be my answer. So 3 plus or minus square root of 2 is my answer. When you do these, let me just check the homework real quick to see if they want you to write that in separately. I guess not on these. So, oh yeah, you do have to write them separately. So when you write these in my open math, what you'll have to do is put 3 plus square root of 2 and then comma 3 minus square root of 2. So in the homework, there's one like this in there where you'll have to put that separate your answers. Unfortunately, there's no plus or minus tool that they give you there. So you want to go ahead and write these out separately like that. So 3 plus, it doesn't matter what order you put those in. You could do minus and plus. It doesn't make a difference there in that case, but that would be your answer. Let's do another one of these. Okay, another complete the square problem. Okay, so complete the square here. All right, so again, the same thing. You're going to leave the x squared plus 8x. We're going to leave a space for the complete the square step. And then the 84, you're going to add that to the other side, it becomes positive. So now we're going to do the step 1 and step 2 of the complete the square. So you're going to take the number in front of the non-squared variable, the 8. I'm going to take 8 divided by, always divided by 2. And then you're always going to square the result after that. So 4 squared equals 16. So again, divided by 2, and then we squared it. The number you get in step 2 is the one that we have to add to both sides of the equation. Okay, so we added 16 to both sides. Automatically, the part on the left-hand side goes into a perfect square that you can factor. That's again why the reason why you're doing the complete the square steps there. You're doing that on purpose to get it to go onto this. It's x, and then the space gets filled in with the answer you got in step number 1. So it's a plus. So we're going to put a +4 in there. Okay, and then if you take 84 and 16, add that together, you're going to get 100. Okay, so now we're going to square root both sides. Square root x plus 4 squared, and we get plus or minus the square root of 100. X plus 4 is going to equal plus or minus 10. Now, what makes this different from the problem that we did above is because we got a square root of 2, and that doesn't combine together with 3 at all, so it's not like terms. Now, because this does go into a whole number, we are going to go ahead and separate this into 2 separate equations. So we're going to do x plus 4 equals 10, and x plus 4 equals negative 10. We're going to subtract 4 from both sides, and we get 6. Subtract 4 from there, and we get negative 14. So your 2 answers are going to be 6 and negative 14. So a question always comes up, could I have factored this? And the answer is yes. This is one we could have factored. We could have looked for 2 numbers that multiply to make 84 and add to be 8. So this is a problem that can be factored. Anytime you have a problem, you get 2 whole number answers or 2 fraction answers. That means you could have factored it, but it says purposely complete the square, so that's why we're doing it by the complete the square method. Okay, so that's the third method. We've done factoring, we've done square root method, we've done completing the square. So it's 3 different ways of solving quadratic equations. Now we got the last one, the fourth one, is the quadratic formula. Okay, so here is the quadratic formula. It's given right here. So you want to assume that you have to have something in standard form first in order to use the quadratic formula. So 0 equals ax squared plus bx plus c. And the a, b, and c that comes from your equation, you're just going to plug those numbers into the formula, and then that's going to get you the answer directly. It doesn't matter if it's something that can be factored or not, it works for anything. So you can just put it into here. So we want to solve by using the quadratic formula. All right, so first for this, we want to identify what the a, b, and c are, because those are the ones that go into the quadratic formula. Now in this case, the a is equal to 1 because there's a 1 in front of the x squared. So a is 1. The b is the number in front of the x, that's a 4. The c is the number that's not attached to an x, and so c equals 2. So I know a, b, and c. All I have to do now is plug those into the quadratic formula to get the answer. So x equals, so I have negative b, negative 4, plus or minus the square root of, okay, I have b squared minus 4ac, so 4 squared minus 4 times the a is 1 and your c is 2. That's all over 2 times a, or 2 times 1. So just plugging that all into the formula. Now I just want to keep on going with this and simplify it as much as possible. So negative 4 plus or minus, I get 16 minus 8. On the bottom, I have a 2. Keep on going with it. X is equal to negative 4 plus or minus. That's going to be square root of 8. That's all over 2. When you get to this point, the square root of 8, you want to see if you can break that square root down more. So the 8 is equal to 4 times 2. So square root of 8, I can write that as square root of 4 times 2. The square root of 4 can come outside of the radical. So square root of 4 is a 2, which means that I can now write that as 2 square root of 2. So I have x is equal to negative 4 plus or minus 2 radical 2 all over 2. The last step is I want to do a factoring step. I can actually divide both of these by, you can either factor out a 2, or in my case, what I'll do is I'm just going to divide each piece by 2, because that's going to allow me to simplify it down further. You want to take this down and simplify as much as possible. So when we divide both of those by 2, we get our answer, -2 plus or minus square root of 2, and that would be the exact answer. Now, quadratic formula, you probably want to do that when factoring does not work. So if factoring doesn't work there in that case, this is actually probably the case where you want to go ahead and use the quadratic formula if it can't be factored. So if something can't be factored, then you really have two choices. You can either do quadratic formula, or you can use the complete the square method. Those are really the two methods you want to go to if it can't be factored. Because if it can't be factored, then most likely you're going to get an answer that has some kind of square root in it. And so that's what happens with that. Let's do another one of those. Okay, so we'll do this one by that. All right, so this here is not in the proper form. So before you do quadratic formula, you always want to make sure that you put it in the proper format. So I need to move both of these on the right-hand side. I'm going to move them over to the left. So 5x squared remains positive. This is going to become a positive 6x and a minus 5. I could have brought these all, I could have subtracted the 5x squared also. I could have done that as well. Makes no difference, but I'll do it this way where the 6 becomes positive and then the 5 becomes negative when you move it across the equal sign. My A is 5, my B is 6, and my C is -5. That's my A, B, and C that I have. I'm now going to go ahead and put these into the quadratic formula. So just to write that out again, so you have it, it's going to be this one right here. We have -b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so 2 times a we have in the bottom. Now let's put everything all into the formula. -6 plus or minus the square root of 6 squared minus 4 times a is 5, and c is -5. All that over 2 times a, 2 times 5. All right, so now we have to simplify that further. So we're going to simplify all this inside. That's 36 minus is a plus, and we're going to get plus 100 there inside, all over 4. Let's keep on going with this. We want to simplify this down as much as possible. Inside we get 136. Okay. Now 136, we're trying to see if we can take something out of this. So I know a perfect square would be a 4. So what I might want to do is maybe take 136 and divide it by 4. And if I do, that does go unevenly. So I'm going to write this as -6 plus or minus the square root of 4 times 34. So I'm looking for trying to divide this by perfect squares. So I want to try and divide it by like a 4, a 9, a 16, something like that. I want to try to find something I can pull out. So in this case, 4 does divide in there. I can't do anything with the 34 because that would just be 2 times 17. So I can't do any more with that, but I can break it down to here. That means that this is going to turn into -6 plus or minus 2 square root of 34 all over 4. Okay, so that one right there, square root of 4 becomes a 2, and that comes outside of the radical sign. Now in this case, I could go ahead and divide everything by 4. Now I did that in the last step. I divided everything. Here's something else that you could do. You could factor out a 2 from the top, and you get just this here all over 4. And then you could reduce this and divide that by each of those divides. And so you get -3 plus or minus the square root of 34 all over 2. And that right there would be something else that you could do. I'm sorry, 2 times 5. Sorry about that. This is to realize I made a mistake here. This is, oops, supposed to be a 10 in the bottom, not a 4. It was 2 times 5 is 10. So all these here, apologies, that should all be equal to a 10 in the bottom for all those. So this is a 10 here, a 10 there, there's a 10 here, 10 there. That means that there should be a 5 down here, not 2. So here is your final answer on that. So you get, this is what you would write in my open math. -3 plus or minus root 34 all over 5. And that would be the reduce. So you do want to try and reduce this as much as possible. In this case, the only thing we could reduce was the 2 and the 10. And the 2 goes away, but there's a 5 still left on the bottom. And that's how you want to do that one. We're going to do one more of these with quadratic formula, and then we're going to go on to the next section. So we're going to do one more problem, because this problem kind of leads into the next problem that we're going to be doing. Another one where we have quadratic formula. My A is 4, my B is -1, and C equals 2. I have the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2 times a. And so now I'm going to go ahead and plug all this in. So I'm going to do, you got to be careful with this. This is -b and my b is negative. So what it looks like is this. I have a negative and a negative. So a double negative I have there in that case. Then I have -1. -1, the whole thing is being squared. So when I square this, the negative is going to go away. -4 times a is 4 and c is 2. All that over 2 times a, 2 times 4. All right, so negative, negative, I get a +1, plus or minus the square root of, this is 1, and if I multiply this, I get 1 minus 32 there, all over 8. Erase this part here. Okay, so now I have all this, and I want to keep on going with this. And notice what happens here is I have 1 minus 32, so I get -31 on top. So I have to square root of -31. Now this right here is not a real number. I can't take the square root of a negative number. So in this section, what I would put is there's a selection button that you'd put that would be no real solution, and that's what you would put for this kind of problem. There's no real solution there, and that is one of the answer choices that you do have on that. And so that's what you would have for your answer. Okay, so there's a button that says there are no real solutions. That's what you would pick for this. It's not a real solution because we can't take the square root of a negative number. That's actually why we need to take a look at the next section, which is the CR 15, which is what we're going to be doing next, because that's going to allow us to do a little bit more with the square root of negative numbers. It allows us to simplify that more. And so that's what we're going to go on to next here in CR 15 with that. So in this section, we're just going to introduce this section today. We're not going to finish all of it. We'll finish it up on Monday. I just want to go ahead and start this so we have plenty of time to cover everything. But we're going to make a this right here. Okay, so this part is the first definition that we're going to say. We're going to say that I is equal to the square root of -1. Now we know that we can't do square root of -1. That's not a real number. So the I is called an imaginary number, or sometimes it's also called a complex number. So of course, if I take I to the first power, I just get I. And I want to go ahead and write some powers of I for you here, because you do need to know these in order to answer some of the questions in the homework. Now, if I do I squared, I would take this definition, and if I square both sides, I would get I squared would equal -1. Okay, so I'm going to make this look like a 1, so you can tell the difference between my 1's and the i's here. So I squared is equal to, if I remove the radical, then I get -1. If I take this and I multiply both sides by one more I, that means I would get -I here. So multiply this side by an I would get I cubed. Multiply this side by an I get -I. And then if I do this one more time, if I multiply both sides by I one more time there, I would get I to the 4th equals -I squared. I squared is -1, so this is actually just equal to +1. You could get that by starting with I squared, and if you have I squared and you square both sides, that's how you get I to the 4th will equal 1. And then what happens after this is if I start over again, so basically if I go I start over, the pattern repeats itself every 4 times. By the way, if I have I to the 0, I to the 0, by the way, is also equal to 1. So if I have I to the 0, I to the 1st power, 2nd, 3rd power, so I have 1 I, -1, -I. Well then, starting from I to the 4th power, the pattern's going to repeat itself over again. It'll be 1 I, -1, -I. The pattern repeats every 4 times. So if you want to do a problem like this where you want to find I raised to a certain power, then what you're going to do is you're going to divide this by 4 and then see what remainder you get. The remainder is always going to be one of these here, and you'll be able to get the number off of your list. So for instance, 38, I want to divide this by 4. Let me give myself a little bit more space for that. Divide this by 4. Now, this is going to go in 9 times, but then there's going to be a remainder of 2. So the 2 down here is your remainder. So what this is saying is I to the 38th power is actually the same thing as I squared. Whatever the remainder is, that's what this simplifies to. And then I just look at my list and I see that I squared is equal to -1. And so that is going to be my exact answer. So now I know that I to the 38th power is the same thing as -1. That's what it simplifies to. So just take whatever the exponent is, divide the exponent by 4, and then whatever your remainder is, you just look at this chart, and then that's going to tell you what the answer is going to be. So let's do another one of those. Let's do I to the 359th power. Okay, so 359, we're going to divide this by 4. That's going to go in there. You got to go 8 times here. That's 32. I get a 3. Now I want to take 4 into 39. That's going to go in there 9 times. And I get a remainder of 3. So now that tells me that I to the 359th power is the same thing as I cubed. I look at my list up here, and I cubed is equal to -I. So that's what I would put for my answer, -I would put in there. This is a multiple choice question that you'll see in the homework. It'll just ask you to simplify something, and then it's going to give you the 4 different choices, and you just put whatever one it is. Then there's one last one we'll try. Again, these you tried it problems, I'll just go ahead and do those for you. For this, it's going to go in there 4 times. 5 up on top, that's 20. Now 4 has to go into 33. It's going to go in there 8 times. And I get 32. I get a remainder of 1. So I to the 233 power is equal to I to the 1st power, or just I would put for my answer with that from the multiple choice. Okay, so that's the first couple of problems you'll see in the homework have to do with that. Okay, so next thing we'll do is we're going to jump to the standard form. And so standard form on that is A plus BI. So you see there's 2 different pieces. You have the real number part, which is the A, and you have the imaginary part, which is your B. And so a type of question it would ask you for here would be to identify what part, the real part and the imaginary part, like these two questions that are down here. And that's really all you have to do is just type all that in. The real part equals and the imaginary part equals. So for this question here, the real part is equal to 4, and the imaginary part is going to equal the number that comes in front of the I, so negative 13 you would put for that. Now you don't put the I for part of that, okay? You don't put the I on there. You just put the number that comes in front of that. So the negative 13 is all you're going to see there, and that's all you got to do for this. If I do the real part for this next one, real part's going to equal, now in this case, there's no number that comes in the front. So in this case, the real part is going to be 0 because there is no number that comes in front of there. But I can always write this as 0 plus 18i, so 0 is the real part there. The imaginary part equals 18. Okay, and that's what you would just put, that's how you would answer that question. All right. Okay, now the next couple questions are asking you to simplify by following the complex number system. So here's the way that you're going to do a question like that. The square root of 144, we're going to break that up into square root of 144 and then times -1, just like that. And then I can break these down into two separate radicals. There's a property that says that we're allowed to do that. We can break these apart. Now the square root of 144 is 12, and then the square root of -1. We talked about that at the beginning of this section. That's equal to I. So the answer to this you just put down would be 12i. Okay, and that's how that's the number written out as a complex number system. So again, that's a type of question that they're going to ask you to do, is just write it as a complex number. Okay. Next one, the square root of -15. Okay, so that one is going to be square root of 15 times -1. So times -1. That can go into square root of 15 times square root of -1. Now, square root of 15 is not a perfect square. That's 3 times 5, so I can't break this down any further. So I'm just going to leave it as square root of 15. But I have square root of 15 and then times I, like that. Now, typically we want to write the I in front of the square root. So when you write your answer, you'll just put it as I square root of 15, like that. Now, the reason why we do it that way is because if I put the I in the end, I might have square root of 15 I like this, but then it might become confusing to know whether or not the I is, if I write it out like this, or if I made my radical maybe just a little bit too long, then it might become confusing knowing, does that I belong inside the radical or outside the radical? It's kind of confusing if you write it that way. So that's why it's preferred to actually write it this way, where you have the I in front of the square root like that. It's actually better, because then you know for sure the I is on the outside of the square root. Okay, let's do we'll do 2 more of these. We'll just go ahead and finish this out here, and then we'll finish up with this one on the top of the next page, because it's a similar one where we're writing it in a complex number form. All right, so we're going to do 80. Now, before I separate this, I want to kind of do a factor tree with the 80 here. If I take 80 and divide it by 2, then I get 40. And 40 divided by 2, I get 20. 20 goes into 4 and 5, and then I have 2 and 2 for this. So 80 is equal to 2 times 2 times 2 times 2 times 5, or I can also write it as 16 times 5 because I'm trying to see if I can find the largest perfect square out of that. So 80 can be written as 16 times 5. And I would want to know that because then I can write this as 16 times 5 times -1, just like that. This is going to give me, if I separate it, then I get square root of 16 times square root of 5 times square root of -1. Well, square root of 16 is a 4, and then I have square root of 5 here, and then I have times I, or I can just go ahead and write that out front. So I'd write it as 4i square root of 5, and that would be my answer for that. So 4i square root of 5 is how I write that in the complex number system. Then we've got 162. So again, if you're not sure how that works, you can always do a factor tree. If it's even like that, I know that I can at least divide it by 2. And so I'll start by taking that 162 divided by 2. And I get 81. Well, 81 is already a perfect square, so I'm going to go, I don't have to break this down anymore. I know that goes into 9 times 9. So I'm actually going to just go ahead and leave it as that. If I find it out as a perfect square, then I'm going to go ahead and leave it like that. So I can rewrite this as I can do 81 times 2 times -1. All that multiplies together to equal -162. Square root of I can write all this out separately, and then square root of 81 becomes 9, and then I have times square root of 2, and then I have times I, and then I can put that together and write 9i square root of 2. That's how I write the number in the complex number system. Okay. Now here is the last problem that we're going to end with today, is this one, because it's kind of similar to the ones we did before where we're writing them in complex number form. Okay, so I have so if I have let's take a look at this, square root of -16. This is the same thing as the square root of 16 times -1. And that would be square root of 16 times the square root of -1, which means I would get 4i for that. Okay, so 4i. So square root of -16 is 16 times -1. Square root of 16 times square root of -1, and I get 4i from that. And then the square root of 4, I can automatically take the square root and write that as 2. So this right here is going to be written as 2 minus 4i. That's how we do that. Okay, so square root of 4 becomes 2. Square root of -16 becomes 4i, and that's going to be it. So I'm going to go ahead and stop at that point. I will go ahead and open up the CR15 section for you, and so that way, if you want to work on that one a little bit over the weekend, you can. And so what I've done would allow you to do probably about the first half of this section. So you should be able to do like the first 9 problems in this section you can now do, since I gave you the notes for this. So I will open up that section for you as well. So over the weekend, I'll continue to go ahead and look at your exams and give you partial credits. So again, you should be getting an email from me that has your new adjusted score from that. And then also I'll give you instructions on how you can check to see what the correct answers were. I'll give you that as well. So at this point, we'll stop now. Does anybody have any questions before we go ahead and end this meeting? All right, looks like not. So I'll go ahead and end the meeting now. Enjoy your weekend. See all of you on Monday.